Need to extend AI solutions beyond out-of-the-box features so agents can work across apps, websites, and Microsoft 365 experiences? Hi, and welcome. I'm Georgia, the technical trainer at Microsoft, and in this session, we'll cover the essential skills that shape how AI gets built and deployed in the enterprise. Let's get started. By the end, you'll be able to design scalable and secure AI solutions on Microsoft platforms, work with custom models in Microsoft Foundry, build and operationalize agents in Microsoft 365 Copilot, extend these agents with Copilot Studio, and learn about the Model Context Protocol, and apply solid governance and lifecycle management. So let's start by talking about designing AI solutions using custom models in Microsoft Foundry. So when do you actually need a custom model? 4 big signals. First, your domain has specialized language that general models struggle with. Think legal, healthcare, or finance. Second, the decisions are high stakes, where accuracy directly impacts compliance or safety. Third, data sovereignty requires you to control every aspect of data handling. And fourth, high-volume inference, where a small specialized model saves significant costs. Always evaluate these factors before committing to a custom path. Now let us talk architecture. Microsoft Foundry gives you an end-to-end platform from data prep to training, evaluation, deployment, observability, and finally governance. The model catalog provides base models you can fine-tune. Training and fine-tuning pipelines help you iterate at scale. Your custom models can plug directly into Foundry agents for multi-step reasoning and automated workflows. Responsible AI controls are built in, including content filtering, safety evaluation, and policy enforcement. And for deployment, you have flexible topologies, hosted secure environments, private networking, and integration with Azure Kubernetes Service, or AKS. As an architect, your best practice is to design with all of these layers in mind from the start, not later. Let's walk through the first 2 design steps. Step 1, define measurable business objectives. Things like accuracy targets, time saved, and cost efficiency. Map these to use cases where custom models genuinely outperform standard copilots. Step 2, assess your data. Check for gaps in labeling, quality, diversity, and structure, and confirm governance policies. Permit training use. Here's the key takeaway. If you cannot measure the outcome, you cannot optimize the model. And if your data is not ready, neither is the model. Steps 3 and 4 are where technical decisions get real. For model selection, you have 3 paths. Fine-tuning a foundation model for adjusted behavior without full retraining. Training a small domain-specific model for speed and edge scenarios, or a hybrid approach, combining both with pre-built copilots. For integration, your model must connect to Dynamics 365, Azure Functions, Logic Apps, Foundry workflows, and your automation pipelines. So make sure you design for integration. A brilliant model that cannot plug into your systems delivers 0 value. Step 5 is validation. You need scenario-based evaluations, safety and bias analysis, plus stress, latency, and scaling tests. But here's what sets great architects apart. Measuring actual ROI and business impact. Does the model save time? Reduce costs? Improve decisions? Establish your success criteria before you build so you know exactly what to measure. And remember, validation is a continuous process. Deploying a custom model is just the start. Operationalizing means setting up monitoring for drift, degradation, and unexpected outputs. Governance controls ensure every deployment meets privacy and regulatory requirements. Versioning with clear rollback strategies protects you when updates go wrong. And MLOps or GenAI Ops pipelines automate validations and approvals. The best practice here is to treat operational readiness as a first-class design requirement from day 1, not something you figure out after the launch. This decision matrix is your quick reference guide. When domain specificity, compliance, performance needs, data confidentiality, workflow complexity, or cost optimization demands are high, go custom. When they are low to moderate, a standard Copilot will serve you well. The key best practice here is to use structured decision frameworks like this rather than gut instinct. Document your reasoning. It builds stakeholder trust and creates a defensible architecture record. Notice this life cycle is cyclical, not linear. From business goals through data collection, preparation, model selection, training, evaluation, deployment, and monitoring, each of these phases feeds back into the next. Your first model version will never be your last. Build feedback loops and capture real-world performance and feed it back into the training. This continuous improvement cycle is what separates experimental AI from production-grade solutions. So make sure every stage has clear ownership and governance checkpoints. In this next section, we will talk about designing agents in Microsoft 365 Copilot. This is where AI architecture meets the daily productivity tools that millions of people already use. Copilot agents are modular, instruction-driven AI components built for specific business tasks. They leverage organizational data through Microsoft Graph. They use connectors and tools to take action, and they operate inside Teams, Outlook, Loop, and SharePoint. Their typical functions include task automation, information retrieval, multi-step operations, and collaboration workflows. The golden rule: design each agent with a single clear purpose. Agents that try to do everything might end up doing nothing well. This visual shows the agent governance lifecycle: design, build, test, deploy, monitor, and improve. Each phase has specific checkpoints. During design, validate the business case. During build, enforce coding standards. Testing must cover edge cases and adversarial scenarios. Deployment needs proper access controls. Monitoring catches drift and quality issues. And the improve phase feeds learnings back into the next cycle. Embed this life cycle into your organization's agent development process every single time. The agent design framework starts with understanding the core problem. Before writing a single instruction, define the task, identify the business goal, determine what decisions the agent must make, and specify which systems it interacts with. Focus on one high-value need like lead prep, case triage, or workflow routing. The best practice is to resist scope creep. A tightly scoped agent that does one thing brilliantly is far more valuable than a do-everything agent that performs poorly. Next, define the agent's behavior explicitly. Give it a clear role, like customer service triage assistant. Specify what it can and cannot do. Set guardrails for tone, content, boundaries, and compliance. And critically identify when escalation to a human is required. Write your agent's behavioral rules as if you're writing a job description. Clear, specific, and with well-defined escalation paths. Vague instructions lead to unpredictable and potentially risky behavior. Agents need data and tools to be useful, and this is where security gets critical. They rely on Microsoft Graph data, SharePoint, OneDrive, and Teams content. You can use built-in connectors or integrate custom APIs, but everything must operate within least privilege and zero trust boundaries. Map your data sources before designing the agents. Know exactly what data it needs, apply minimum permissions, and audit access regularly. An agent with excessive access is a security liability, no matter how useful it is. Collaborative agents are where things get really powerful. Sequential workflows pass output from agent A to agent B. Parallel evaluation has multiple agents analyzing data simultaneously. Feedback loops refine content iteratively, and orchestrated interaction delegates subtasks based on intent. The critical best practice? Make sure you define clear handoff rules and responsibility boundaries. When agents collaborate, ambiguity is your enemy. Document who does what, when and what happens when something goes wrong. Agent Builder in Microsoft 365 Copilot is your guided environment for creating declarative agents. It walks you through defining purpose, adding instructions and guardrails, and connecting data sources, configuring actions and permissions, and testing with sample prompts. And finally, publishing. What makes it powerful is that it enforces clarity and enterprise-grade safety by design. Use the testing workspace extensively before publishing. Test with real-world scenarios, edge cases, and adversarial prompts to validate behavior. This image shows the complete agent flow in Microsoft 365. A user action triggers the agent through Teams or Outlook. The agent processes through its instructions and policies, then leverages tools and connectors, including Microsoft Graph and APIs. Then it executes business logic and returns the response. Every connection point is a design decision, a security boundary, and a governance checkpoint. Trace your specific use case through this architecture and identify where you need customization versus standard capabilities. Managing Copilot agents is an ongoing responsibility, not a set-and-forget exercise. Your operational duties include monitoring agent quality and user feedback, updating instructions to maintain accuracy, enforcing access control and data protections, reviewing logs for compliance, versioning agents through governance processes, and identifying new scenarios based on user demand. The best practice is to establish a regular cadence for agent reviews, not just when something breaks. Proactive monitoring catches issues before users notice them. And always version your agents so you can roll back if an update causes problems. When designing new agent scenarios, ask these 4 questions. Does it require cross-application contexts? Do users benefit from automated task execution? Will it support frontline or knowledge workers? What latency, safety, or reliability constraints apply? These help you scope properly and avoid over-engineering. Validate each scenario with real users before full development. A quick prototype can reveal whether the agent adds genuine value or whether a simpler solution would work better. Next, we will discuss how to design agent extensibility in Copilot Studio. This is where you learn to go beyond basic agents and build truly enterprise-grade, extensible solutions. Copilot Studio extensibility covers 5 focus areas: adding custom logic and behaviors, integrating enterprise systems through connectors and APIs, modifying agent instructions with prompt modification techniques, extending with Visual Studio Code for advanced scenarios, and supporting governance and lifecycle controls. The best practice is to design for extensibility from day one. An agent that cannot be extended becomes technical debt. Build modular, loosely coupled components that can evolve independently. Instruction-level extensibility is the foundation of agent behavior. It defines purpose, role, constraints, action patterns, and escalation rules, essentially the agent's DNA. Prompt modification features let you add custom rules without rebuilding the entire agent. Layer your instructions. Start with core immutable rules, then add contextual layers that can be modified per scenario. This gives you stability at the core with flexibility at the edges. Always document your instruction hierarchy. Skills and capabilities define what your agent can actually do. Common extensions include retrieval skills using enterprise content, action-oriented skills through the Power Platform connectors or custom APIs, multi-step workflows for structured tasks, and domain knowledge to reduce hallucinations. The key is to create modular, reusable skills shared across multiple agents. Think of skills like building blocks, designed to snap together in different combinations. This prevents duplication and ensures consistency across your agent portfolio. Integration extensibility makes agents truly enterprise-grade. Your agents need to interact with systems of record, execute actions through Power Automate, interact with external APIs, and publish events. But here's where we need to earn our keep. You must consider data governance, least privileged access, standardized commands, and consistent entity mapping. Create an integration catalog documenting every external system, the data accessed, and permissions required. This becomes your security and compliance foundation. Pro-code extensibility using Visual Studio Code opens the door to advanced scenarios, like custom agent logic, reusable components, data transformations, orchestration, and many more. It is ideal for high-complexity behaviors and deep integration patterns. But here's the best practice. Start with low-code options first and escalate to pro-code only when you hit real limitations. This keeps solutions maintainable and accessible to a broader team. Do not use a hammer when a screwdriver will do. The modular agent architecture pattern structures agents using interchangeable components, instructions, skills, integrations, and tools. This enables faster updates because you change one module without touching others. Module reuse across multiple agents and better isolation for compliance and security. Make sure you enforce clear interfaces between modules. When each component has well-defined inputs, outputs, and contracts, you can swap, upgrade, or replace them independently. This is software engineering discipline applied to AI. In complex environments, one agent should never do everything. The multi-agent collaboration pattern uses specialized agents working together through defined protocols. A research agent retrieves data, a workflow agent executes tasks, and a communication agent drafts content. Design clear communication contracts between agents. Each one needs a well-defined scope, and handoff points must be explicit and auditable. Think of it like a well-organized team where everyone knows their role and their process for passing work. The domain context pattern makes agents smart within specific business contexts. The agent adapts its reasoning based on the system, environment, or domain it operates in, using domain-specific terminology, business rules, access policies, and expected outcomes. The best practice is to externalize your domain context so it can be updated without modifying the agents. Store business rules and constraints in a configuration layer that the agent reads at runtime. This makes agents adaptable to changing conditions without redeployments. Microsoft has developed a formal framework of principles and patterns for architecting agent solutions. It establishes industry standards, provides recommended guidance, ensures quality through reliability and traceability. And it enables scale with best practices and aligns standards across your organization. Do not reinvent the wheel. Use these patterns as your foundation and customize for your specific context. This saves time, reduces risk, and ensures alignment with proven best practices. Let us be clear about scope. This framework covers fit-for-purpose operability, trust, traceability, and transparency, which are the essentials for enterprise agent solutions. It does not replace the Azure Well-Architected Framework, the Power Platform Well-Architected, or NIST security frameworks. Those still apply. Layer these frameworks together. Use agent architecture guidance for agent-specific concerns on top of your existing security and infrastructure frameworks. This gives you comprehensive coverage without gaps. This visual shows the 4 extensibility layers. Work from top to bottom. Start with instruction level changes. They are cheapest and fastest. Only move deeper when upper layers cannot meet requirements. This approach minimizes complexity and maximizes maintainability. So let's move on to an exciting section, how to design agent extensibility with Model Context Protocol, or MCP, in Copilot Studio. MCP serves as a structured contract defining what context an agent can access and how to interpret it. In Dynamics 365 F&O, it exposes business entities, relationships, labels, metadata, and domain-specific objects. This ensures consistent business semantics across all your agents. It reduces hallucinations by grounding in real data. It enables multi-app interoperability and improves explainability. Treat MCP as your single source of truth for business context across your entire AI portfolio. Designing extensible agents with MCP starts with modular, layered instructions. Every agent needs 5 core components: a purpose statement that clarifies its primary function, a role definition that sets tone and perspective, behavior rules for compliance and safety, context consumption logic that defines how MCP data is used, and action boundaries that define approved capabilities. The best practice is to keep each component independent and versionable. When compliance rules change, you should be able to update the behavior rules layer without touching the purpose statement or role definition. This modularity is what makes your agents extensible and maintainable at scale. Context extensibility through MCP is where agents become intelligent about your business. MCP exposes structured information, Dynamics 365 data entities like customers, vendors, and products, business process metadata, including workflows and approval chains, or domain models like financial dimensions, and also localization rules. This enables agents to understand business terminology, pull relevant structured context for reasoning, produce accurate and policy-aligned responses, and generate explanations that align with business rules. The best practice is to invest in the quality of your MCP context definitions. Garbage in, garbage out applies here. Well-structured, well-labeled context models produce dramatically better agent behavior. There are 3 key integration patterns for MCP-enabled agents. The first pattern is context-driven reasoning. Agents retrieve real-time MCP context to ensure responses reflect authoritative business rules. This is ideal for compliance-sensitive tasks, finance workflows, and procurement scenarios. The second pattern is workflow-integrated agents that use MCP to drive approvals, escalate exceptions, and summarize status. Pattern C is a multi-agent collaboration via MCP, which standardizes data across agents for cross-domain collaboration. Think HR, finance, and supply chain working together. The best practice is to select your pattern based on the business scenario, not the technology. Each pattern serves different needs, and mixing them thoughtfully creates powerful composite solutions. Governance and compliance for MCP-enabled agents require attention to 5 key areas. Data access must be governed by user identity following least privilege. MCP context boundaries must align with compliance controls. Agent decisions must be logged for auditability. Instructions must enforce responsible AI behavior, and ownership must be established through an AI Center of Excellence model. The best practice is to make governance automated, not manual. Build compliance checks into the agent pipeline so they happen automatically with every deployment. Manual governance does not scale, and in a fast-moving AI landscape, slow governance means either unsafe deployments or stalled innovation. The extensibility layer model shows 4 stacked layers. The best practice to think about is to design each layer to be independently testable. You should be able to test instructions without integration, test MCP context retrieval independently, and verify guardrails in isolation. This layered testing approach catches issues early and makes debugging much faster. Think of it like testing a building. You check the foundation before you worry about the roof. This workflow shows the complete MCP flow. The critical step is reasoning, where the agent aligns its thinking with the business rules from MCP. This prevents hallucinations and ensures grounded responses. Monitor this step closely, log what context was retrieved, what rules applied, and how the agent reached each response. This explainability builds trust and meets regulatory needs. So now we're entering an exciting frontier, designing agents that automate tasks in applications and websites using computer use in Copilot Studio. Computer use allows agents to interact with user interfaces in powerful ways, like controlling mouse and keyboard, navigating websites and desktop apps, reading on-screen text, performing multi-step tasks, and automating repetitive workflows. The process works like this. The agent receives a user request, analyzes the user interface using a vision and reasoning, generates a step-by-step plan, and then performs actions through the computer use channel. And finally, it validates the results. The best practice is to design agents that validate after every action step, not just at the end. UI-based automation is inherently less predictable than API-based automation, so continuous validation is your safety net. When should you use computer use? The first major scenario was when no API or connector exists. Legacy systems built before APIs were standard, vendor portals you could not control, and desktop-only applications. But here's the thing, always check for API alternatives first. Computer use is a power fallback, but it is more fragile than API-based integration. Reserve this capability for situations where there's genuinely no programmatic alternative. The second scenario where computer use shines is repetitive UI-driven tasks, data entry, form submission, and copy-paste workflows. These are the kinds of tasks that humans find tedious and error-prone, making them perfect candidates for automation. The best practice is to thoroughly document the exact steps of these workflows before building the agent. A well-documented workflow translates directly into reliable agent instructions. Also consider the volume. If a task happens hundreds of times a day, the ROI on computer use automation can be enormous. The third scenario is tasks that require navigating multiple applications, pulling data from a website and entering it into a CRM, downloading reports from portals, or updating spreadsheets based on UI data. These cross-application workflows are where human workers spend significant time context switching. The best practice is to design your agent to handle each application independently and compose the workflow from those building blocks. This approach means that if one application changes its UI, you only need to update that one module, not the entire workflow. The fourth scenario requires human-like reasoning, identifying the correct button on a dynamic page or navigating menus that change based on context. This is where computer use really differentiates itself from traditional automation tools like simple screen scrapers. The agent applies reasoning to understand what it sees and decides what to do next. The best practice is to provide descriptive instructions that help the agent understand intent, not just actions. Instead of saying, click the third button, say, click the blue submit button. This makes your agent more resilient to UI changes. When designing agents for computer use, start by defining the task clearly. Agents perform best when tasks are specific, goal-oriented, and structured. A good example: log into the vendor portal, download the latest invoice, and save it to SharePoint. Notice how specific that is? It names the system, the action, the object, and the destination. The best practice is to write task definitions that a new employee could follow on their first day. If a human would need clarification, your agent will too. Clarity in task definition directly translates to reliability in execution. Agents need guardrails to operate safely. Define which apps or sites they may access, what data they may interact with, what actions are prohibited, and set time or retry limits. This is not optional, it's essential. Without guardrails, a computer use agent could accidentally navigate to the wrong site, enter data in the wrong field, or get stuck in an infinite retry loop. The best practice is to be explicit about what is off limits. It is better to have an agent that occasionally asks for help than one that confidently does the wrong thing. Default to restrictive permissions and open up only what is needed. Even though computer use agents can reason, breaking tasks into explicit steps dramatically improves reliability. Design a clear workflow, open the website, log in, navigate to invoices, download the file, upload to SharePoint. Each step is a checkpoint where the agent can validate success before moving on. The best practice here is to include validation criteria for each step. How does the agent know the login succeeded? What confirms it is on the right page? These validation points are your quality assurance built directly into the workflow design. They catch errors early before they cascade into bigger problems. UI elements change, buttons move, labels get updated, pages get redesigned. Your agents must be designed for this variability. Use descriptive instructions that reference visual characteristics, not just positions. Have the agent validate results after each step and design graceful error handling for when things do not match expectations. The best practice is to build your computer use agents with the expectations that the UI will change. This mindset leads to more resilient designs, descriptive rather than positional references, robust validation, and clear fallback behaviors. Test regularly against the actual UI to catch changes early. Configuring computer use in Copilot Studio starts with enabling it in your agent settings and configuring permissions for allowed applications. This sounds simple, but it is a critical governance step. The best practice is to follow the principle of least privilege. Only enable access to the specific applications your agent needs. Maintain an inventory of which agents have computer use enabled and what applications they can access. This inventory becomes essential for security audits and compliance reviews. Treat computer use permissions with the same rigor you would apply to any service account in your enterprise. Computer use agents can perform several types of actions: clicking elements, typing text, scrolling, extracting text from the screen, and navigating between pages. Each action type has its own considerations for reliability and safety. Make sure you combine these actions thoughtfully. For example, after typing text into a field, extract the field value to verify it was entered correctly. After clicking a button, check that the expected page or element appeared. This action verification pattern is what makes computer use agents production ready, rather than just demo ready. Reasoning mode is what makes computer use agents intelligent rather than just scripted. In reasoning modes, the agent interprets complex UI layouts, identifies the right elements to interact with, and decides next steps dynamically based on what it sees. This is crucial for handling dynamic pages where elements shift or appear conditionally. The best practice is to use reasoning mode for navigation and decision points, but combine it with explicit instructions for known, stable workflows. This hybrid approach gives you the reliability of scripted actions with the flexibility of intelligent reasoning where you need it. Testing is absolutely critical for computer use agents. The Copilot Studio test canvas lets you watch the agent perform actions in real time, validates UI navigation accuracy, and debug failures. This observability is invaluable during development. The best practice is to test with realistic data and scenarios, not just happy paths. Test what happens when the login fails, when a page loads slowly, when an expected element is missing. These edge cases are where computer use agents are most likely to stumble, and discovering them in testing is much better than discovering them in production. Security and access control for computer use agents require special attention. Limit which applications the agent can access, avoid sensitive data entry unless absolutely necessary, and apply least privilege principles rigorously. Remember, a computer use agent is essentially a digital worker with access to your UI. Treat its permissions accordingly. The best practice is to isolate computer use agents in controlled environments where possible. Use dedicated service accounts with minimal permissions, and ensure that any credentials the agent uses are managed through your enterprise secret management system, not hard-coded in the instructions. Responsible AI applies to computer use agents just as much as any other AI system, perhaps even more so, because these agents take visible actions in the real world. Ensure transparency so users always know when an agent is acting on their behalf. Avoid automating harmful or risky actions, and log every actions for auditability. The best practice is to design a comprehensive audit trail that captures not just what the agent did, but what it saw on the screen, what decisions it made, and why. This level of logging is essential for debugging, compliance, and building trust with users and also stakeholders. Reliability is the Achilles heel of UI-based automation. When our website or application updates its interface, your automation can break. This is fundamentally different from API-based integration, where contracts are explicit. So the best practice here is threefold. Build monitoring that will alert you where agent success rates drop, maintain fallback plans for manual execution, and use computer use only when APIs are genuinely unavailable. Also consider establishing a regular testing cadence, weekly or monthly, to verify that your computer use agents still work correctly against their target applications. This diagram shows the complete computer use workflow, from user request through agent reasoning. The best practice is to monitor each segment of this architecture independently. Track reasoning accuracy, action success rates, and validation outcomes separately. This monitoring lets you identify exactly where issues occur and fix them quickly. This visual summarizes the scenarios for computer use. Use this as your decision guide. The best practice is to create a scoring matrix for your automation candidates. Rate each scenario on API availability, task volume, complexity, and business value. Prioritize high-volume, high-value scenarios where no API exists. This structured approach ensures you invest your computer use development effort where it delivers the most impact. Now let's talk about designing agent behaviors in Copilot Studio, including reasoning and voice modes. Agent behavior is shaped by four main components: instructions define purpose, persona, goals, tone, and guardrails. Knowledge governs what content the agent can access and how it retrieves information. Actions and tools let the agent execute tasks, retrieve data, and call downstream systems. And policies and constraints ensure compliance, privacy, and responsible AI. The best practice is to ensure these four components form a consistent, coherent behavioral framework. If your instructions say one thing but your policies restrict something else, the agent will produce confusing or contradictory responses. Alignment across all four components is essential for predictable agent behavior. Here are the key behavior design principles every architect should follow. Provide specific role definitions. Establish allowed and disallowed behaviors explicitly. Define escalation patterns for when the agent encounters situations beyond its scope. Apply formatting rules for consistent responses, and include business logic constraints and error handling expectations. The best practice is to write these principles down in a behavior specification document that lives alongside your agent code. This document should be reviewed by business stakeholders, not just developers. When business people validate your behavior design, you get better outcomes and fewer surprises in production. Copilot Studio supports two reasoning modes, standard and deep. Standard reasoning handles conversational responses, summaries, simple calculations, and basic workflow assistance. It is fast and cost-efficient. Deep reasoning is for heavy-duty work, multi-step tasks, complex business rules, analytical processes, structured decision trees, and scenario planning. It enables the agent to think through problems step by step, validate assumptions, and produce more accurate responses in areas like finance, compliance, and engineering. The best practice is to use standard reasoning as your default and enable deep reasoning only for scenarios that truly need it. Deep reasoning costs more in compute and time, so apply it strategically. When should you enable deep reasoning? 5 key scenarios. When high-precision logic is required, when multi-stage evaluation is needed, when recommendations must be based on historical data, when tasks require constraints and validation logic, and when advanced problem decomposition is necessary. The best practice is to validate these criteria with your business stakeholders. Deep reasoning is powerful, but it also takes longer and costs more. Ensure the business value justifies the investment. If a standard reasoning response with good instructions gets you 90% accuracy, deep reasoning might not be worth it for that scenario. The instruction layer is where the magic happens, or where things can go wrong. Agents rely heavily on instructions for predictable results. Your instructions must be task-specific, stating what the agent must accomplish. They must be role-aligned, defining who the agent acts as. They must be context-aware, including business goals and policies. They must be structured, defining the required output formats. And finally, they should be guardrail controlled. That means preventing unwanted behaviors. The best practice is to treat instruction design as a craft, not an afterthought. The difference between a mediocre agent and an excellent one is almost always the quality of the instructions. Invest a little bit of time here, it will pay in the end. Here's the recommended instruction structure. Purpose tells why the agent exists. Scope defines what it can and cannot do. Tone and style set how it communicates. Data boundaries specify allowed sources. Quality expectations define accuracy and format standards. Error handling covers uncertain situations. And escalation conditions identify when humans must step in. The best practice is to address every single one of these elements for every agent you design. Skipping even one creates gaps that leads to unpredictable behavior. And review this structure regularly. As business needs change, your instruction should evolve too. Voice interactions open up a whole new dimension for agent design. Copilot Studio supports voice-based interactions for hands-free workflows and natural communication. Use cases include customer service, IVR, field technician support, sales routing, healthcare triage, facility operations, and HR or IT self-service. But voice is fundamentally different from text. You need short, clear phrasing, confirmation steps, and you must design for interruptions and backtracking and confidence checks before executing any actions. The best practice is to prototype voice interactions by literally speaking the conversation out loud. If it sounds awkward when you say it, it will sound awkward to your users. Voice agents must be conversational, concise, and forgiving of how real people talk. Let's review with 5 key behavior patterns. Step-by-step reasoning breaks complex tasks into manageable steps for better accuracy. Validation prompting has the agent verify assumptions and confirm missing context before acting. Context reuse carries summaries and reasoning from earlier in the conversation. Intent routing identifies the user's purpose and routes to the right knowledge, action, or workflows. And behavioral guardrails explicitly prevent the agent from doing things it should never do. The best practice is to combine these patterns. The most effective agents use all 5. They reason step by step, validate before acting, remember context, route intelligently, and stay within boundaries. Master these patterns and your agents will be reliable, safe, and genuinely helpful. Before we wrap up, let's discuss optimizing solution design using agents in Microsoft 365 with a focus on Teams and SharePoint. In Teams, agents respond to questions in chats and channels. They automate workflows triggered by messages and provide contextual answers using Microsoft 365 data. Imagine a project team member asking a question and an agent immediately pulling relevant documents, summarizing updates, and suggesting next steps. Design Teams agents that enhance existing conversations rather than creating separate surfaces. The most successful agents show up where people are already working. In SharePoint, agents retrieve content from sites, lists, and libraries. They answer site-specific questions. They support content management, and they provide contextual help based on the site's structure. If your sites are unstructured with a lot of random data, your agent might hallucinate. Content quality is the foundation of agent quality. Grounding is what makes Microsoft 365 agents trustworthy. They automatically respect user permissions. They use Microsoft Graph for retrieval, and they provide answers based on actual enterprise contents. Users never see information they are not permitted to access. Validate your permission model before deploying agents. If permissions are incorrect, you either expose too much, which is a security risk, or show too little, which frustrates users. Run permission audits as part of your deployment checklist. SharePoint integrated agents access site pages, document libraries, lists, news, policies, and wikis. They handle scenarios like finding HR policies, summarizing documents, and checking permissions. They automatically adapt to the site they're on, and they assist with authoring, suggesting metadata, and improving accessibility. Start with the most requested content scenarios. Check search analytics, talk to site owners, and identify the top questions. Nail those first, and then expand. Teams integrated agents handle conversational automation like answering questions and triggering workflows, multi-user collaboration in group conversation, and task automation from creating tasks from messages to summarizing channel activity. Design with collaboration in mind, not just individual productivity. The real power comes when an agent helps an entire team work together, surfacing shared knowledge, keeping everyone aligned, and automating the routine work that slows teams down. Optimizing solution design across Microsoft 365 means getting four things right. First, your grounding strategy. Use SharePoint sites as primary knowledge sources, Microsoft Graph for cross-tenant retrieval, and ensure content is well structured and tagged. Second, permissions and security agents inherit user permissions and respect security boundaries. Third, prompt and behavior design provide concise contextual answers and use SharePoint metadata to improve accuracy. Fourth, governance and lifecycle version control, usage monitoring, periodic content review, and alignment with your AI Center of Excellence. The best practice is to treat these four dimensions as a balanced scorecard. Weakness in any one area undermines the whole solution. Here are four proven solution patterns for Microsoft 365 agents. Pattern 1, the SharePoint Knowledge Assistant that answers site questions and provides document summaries. Pattern 2, the Teams Project Assistant that supports project teams with channel summaries and task automation. Pattern 3, the Organizational Policy Assistant that retrieves policies and provides grounded compliance answers. Pattern 4, the Site Owner Support Agent that helps maintain SharePoint sites and drafts content. The best practice is to start with one pattern, prove its value, and then expand. Each pattern can be a template for similar agents across your organization. Build one, deploy many. That's how you scale AI across the enterprise. This diagram shows how Microsoft 365 agents work end-to-end. Users' requests flow through Teams or SharePoint interfaces to the Copilot Studio agent, which accesses Microsoft Graph and SharePoint content to produce grounded responses. Make sure you pay attention to the data flow. Every connection is a design decision about security, performance, and reliability. The best practice is to validate this architecture with your security team before deployment. Ensure data classification labels are respected, ensure the agent cannot exfiltrate sensitive data, and ensure audit logging captures all interactions. Let's recap what we have learned. You can now design scalable and secure AI solutions using Microsoft platforms, leverage custom models in Microsoft Foundry, design and operationalize agents in Microsoft 365 Copilot, extend agent capabilities using Copilot Studio and the Model Context Protocol, and apply governance and lifecycle management. As an agentic AI architect, remember that extensibility, governance, and responsible AI are not just features, they are foundational principles. We've covered a lot in this session. There are many ways to continue your learning journey. Keep the momentum going by exploring the rest of the videos in this course or discovering your next favorite topic on Microsoft Learn at aka.ms/learn. Thank you for watching. Now you know when to build and when to innovate.